Okay. Once again, good morning, all of you. So, in last lecture, we have completed the unit number 5, that is condensation and boiling. In the last lecture, we have completed the unit number 5, boiling and condensation. Okay. So, from section already we have completed the section 1, and from section 2 we have completed the unit number 5 and unit number 6. So only one topic is remaining, that is unit number 4, that is convection. Okay, so all of you give the new heading, unit 4 convection. All of you give the new heading, unit number 4, unit number 4 convection, unit number 4 convection. Okay, unit number 4 convection. So write down the syllabus for this unit number 4 syllabus. Write down the syllabus of unit number 4. Write down. Write down. In convection, basically there are two parts, that is forced convection and natural convection. In convection, there are basically two types, forced convection and natural convection. So we have to complete first forced convection, then we have to complete the natural convection. So all of you write down the first point, that is forced convection. Write down forced convection, forced convection, forced convection. In that, write down the syllabus for the forced convection. Write down mechanism of mechanism of mechanism of convection, mechanism of convection and its types, mechanism of convection and its types, and its types, mechanism of convection and its types, comma, concept of hydrodynamic and thermal boundary layer. Next point, concept of hydrodynamic and thermal boundary layer, concept of hydrodynamic and thermal boundary layer, hydrodynamic and thermal boundary layer, concept of hydrodynamic and thermal boundary layer, comma, next point, local and average convective coefficient, local and average convective coefficient, local and average convective coefficient, local and average convective coefficient. Okay, the next point, dimension dimensional analysis, dimensional analysis, dimensional analysis, dimensional analysis, comma, dimensionless numbers, dimensionless numbers, dimensionless numbers, dimensionless numbers and their physical significance, dimensionless numbers and their physical significance, dimensionless numbers and their physical significance, comma, empirical correlations for, empirical correlations for, empirical correlations for, empirical correlations for internal and external flow, empirical correlations for internal and external flow, internal and external flow in forced convection problems, empirical correlations for internal and external flow in, internal and external flow in forced convection problems, forced convection problems, forced convection problems, full stop, in bracket numerical treatment, in bracket numerical treatment. Okay, so this is the syllabus related to the forced convection. This is the syllabus related to the forced convection. Then second, write down second point in the convection topic, that is natural convection. Write down natural convection, and write down the syllabus for the natural convection. Write down natural convection. Write down introduction, 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 comma, dimensional analysis, introduction, comma, dimensional analysis, comma, dimensionless numbers, dimensionless numbers, dimensionless numbers, and their physical significance, dimensionless numbers and their physical significance, dimensionless numbers and their physical significance, comma, empirical correlations for, empirical correlations for, empirical correlations for internal and external flow, empirical correlations for internal and external flow, internal and external flow in forced convection problems, sorry, in natural convection problems, empirical correlations for natural convection problems, empirical correlations for natural convection problems, in bracket numerical treatment, numerical treatment. Okay, so what is the syllabus for the natural convention? Once again, introduction, then dimensional analysis, then dimensionless numbers and their physical significance, then empirical correlations for natural convection problems, in bracket numerical treatment. Okay, so this is the unit number 4, convection. In that there are 2 points, forced convection and natural convection. In this topic we have to cover the points as a mechanism of convection and its types. What are the different types of the convection? What is the mechanism of convection? Then we have to understood what is the concept of hydrodynamic and thermal boundary layer. What is meant by thermal boundary layer? What is meant by hydrodynamic boundary layer? Okay, so that part we have to cover. Then what is meant by local and average convective coefficients? What is meant by local heat transfer coefficient, then average heat transfer coefficient? We have to understood this concept. Okay, after that we have to understood what is meant by dimensional analysis, then what is meant by dimensionless numbers. Okay, and what is the physical significance of that dimensionless numbers. Okay, then empirical correlations for the forced convection. So by using that empirical correlations we have to find out the heat transfer coefficient for that particular forced convection. Okay, so from this topic some of the part already we have learned in the second year, that is fluid mechanics. In fluid mechanics we have covered this, what is meant by dimensional analysis, what is meant by dimensionless numbers. Okay, then what is meant by hydrodynamic thermal boundary layer. So that point already covered in the fluid mechanics subject in the second year. Okay, so once again we have to cover this part related to the heat transfer, related to the heat transfer. Okay, and after that we have to cover the natural convection. Then what is meant by natural convection, what is meant by dimensionless analysis for the natural convection, what are the dimensionless numbers for the natural convection and their physical significance. Then we have to see the empirical relations to solve the heat transfer coefficient. Okay, so this is the syllabus for the unit number 4, that is convection. Okay, so write down the first point, convection. Write down what is meant by convection. Write down. We have to understood what is meant by convection, as we know that there are 3 modes of the heat transfer. Basically, there are 3 modes of the heat transfer, that is conduction, convection and radiation. So in the conduction, heat transfer is takes place due to the physical contact, and for the convection, heat transfer due to the motion of the molecules. Convection मध्ये जी काही heat transfer होणार आहे ती कशामुळे होणार आहे? ड्यू टू दी मोशन ऑफ दी मॉलिक्युल्स. कारण कंडक्शन मध्ये फिजिकली मोशन नसणार आहे, तिथं फक्त फिजिकल कॉन्टॅक्ट मध्ये मॉलिक्युल्स असणार आहेत आणि त्या कॉन्टॅक्टमुळे हीट ट्रान्सफर होणार आहे. दॅट इज नथिंग बट कंडक्शन. पण कन्व्हेक्शन मध्ये काय होणार आहे तर मॉलिक्युल्स एनर्जी गेन करणार आहेत आणि त्या एका जागेवरून दुसऱ्या जागेला एनर्जी ट्रान्सफर करणार आहेत. म्हणजे जी काही एनर्जी ट्रान्सफर होणार आहे ती कशामुळे होणार आहे? बिकॉज ऑफ दी मोशन ऑफ दी मॉलिक्युल्स. अँड ॲज वी नो दॅट व्हॉट इज मीन बाय रेडिएशन, रेडिएशन इज नथिंग बट ही ट्रान्सफर इन द फॉर्म ऑफ इलेक्ट्रोमॅग्नेटिक वेव्हज. म्हणजे तिथं कुठल्याही मीडियमची गरज नाही. कंडक्शन आणि कन्व्हेक्शन व्हायचं असेल तर तिथं तुम्हाला मीडियम पाहिजेच. विदाउट मीडियम देर इज नो पॉसिबिलिटी ऑफ कंडक्शन अँड कन्व्हेक्शन हीट ट्रान्सफर. ओके, सो हीट ट्रान्सफर इज पॉसिबल इन दी व्हॅक्यूम बाय युझिंग दी रेडिएशन. रेडिएशन म्हणजे काय? जरी व्हॅक्यूम असलं तरी हीट ट्रान्सफर होणार आहे. देर इज नो नीड ऑफ एनी मीडियम टू ट्रान्सफर दी हीट. ओके, जी काही इलेक्ट्रोमॅग्नेटिक वेव्हच्या फॉर्म मध्ये हीट ट्रान्सफर होणार आहे दॅट मोड इज नथिंग बट radiation mode of heat transfer. Radiation mode of heat transfer. Okay, so all of you write down the concept related to the convection. Write down first point, convection. Write down convection is the mode of energy transfer. Write down convection. Convection is the mode of energy transfer. Convection is the mode of energy transfer between a solid surface and the adjacent liquid. Convection is the mode of energy transfer between a solid surface and the adjacent liquid or gas. A solid surface and the adjacent liquid or gas that is in motion and it involves the combined effects of conduction and fluid motion. Combined effects of conduction and fluid motion. 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 Full stop. Next para. Heat transfer by, therefore, heat transfer by conduction. Heat transfer by conduction and due to bulk motion of heat transfer by conduction and due to bulk motion of fluid molecules. Heat transfer by conduction and due to bulk motion of fluid molecules called as convection. Called as convection. Okay, so heat transfer by conduction and due to the fluid motion. ओके, एक सॉलिड सरफेस असणार आहे, त्याच्यावरती लिक्विड असेल तर तिथं जी हीट सॉलिड मध्ये होणार आहे ती कंडक्शन मुळे होणार आहे आणि त्याच्यानंतर लिक्विड मध्ये जी काही हीट ट्रान्सफर होणार आहे ती ड्यू टू दी कन्व्हेक्शन होणार आहे. म्हणजे ड्यू टू दी मोशन ऑफ दी मॉलिक्युल्स. Okay, then write down the types of convection. Okay, so as we know that basically two types of convection is there: forced convection and natural convection. Okay, so what is the another name for the natural convection? That is free convection. Okay, so all of you write down the types of convection. Write down the types. Write down first type. That is free convection oblique natural convection. 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 Okay. Then second type, forced convection. Second type, forced convection. Second type, forced convection. Forced convection. Okay. So write down. Once again, we have to write down the first type, that is free convection or natural convection. Free convection or natural convection. So what is the difference between free convection or natural convection and forced convection? Natural convection कशाला म्हणायचं आणि forced convection कशाला म्हणायचं? तर natural, what is meant by natural convection? The motion of a fluid is due to the density difference. जे काही फ्लुइड आहे त्या फ्लुइडला जी काही मोशन मिळणार आहे ती कशामुळे मिळणार आहे? बिकॉज ऑफ दी डेन्सिटी डिफरन्स. Because of the density difference, and due to that density difference heat transfer is takes place. That type of convection is nothing but natural convection. Okay. Natural convection मध्ये जे काही मॉलिक्युल्स मूव्ह होणार आहेत, जी काही मोशन असणार आहे मॉलिक्युल्सला, ती कशामुळे असणार आहे? बिकॉज ऑफ दी डेन्सिटी डिफरन्स. अँड बिकॉज ऑफ दॅट डेन्सिटी डिफरन्स heat transfer is takes place. That type of convection is nothing but natural convection. Okay, that type of convection is nothing but natural convection. And then what is meant by forced convection? Forced convection is nothing but the transfer of fluid due to the external means. म्हणजे जी काही लिक्विड असणार आहे किंवा जो काही गॅस असणार आहे त्याला जी काही मोशन असणार आहे ती आपण एक्सटर्नल डिव्हाइसचा यूज करून ती मोशन प्राप्त होणार आहे. ओके. The transfer of fluid due to the external means such as fan, blower, pump, etc. ओके. तर फॅन, पंप, ब्लोअर ह्याचा यूज करून आपण त्या फ्लुइडला काय करणार आहे? मोशन देणार आहे. अँड ड्यू टू दॅट हीट ट्रान्सफर इज टेक्स प्लेस. दॅट इज नथिंग बट फोर्स्ड कन्व्हेक्शन. फोर्स्ड म्हणजे आपल्याला फोर्स लावायचा आहे आणि हा फोर्स कशाच्या सहाय्याने लावायचा आहे? आपल्याला त्यासाठी एक्सटर्नल डिव्हाइसेस यूज करायचे आहेत. म्हणजे पंप असेल, ब्लोअर असेल. ओके. तर ह्या डिव्हाइसचा यूज करून आपण त्या फ्लुइडला काय करणार आहे? मोशन देणार आहे. आणि बिकॉज ऑफ दॅट मोशन हीट ट्रान्सफर इज टेक्स प्लेस. दॅट टाइप ऑफ कन्व्हेक्शन इज नथिंग बट फोर्स्ड कन्व्हेक्शन. नॅचरल कन्व्हेक्शन मध्ये जी काय मोशन असणार आहे ती डेन्सिटी डिफरन्स मुळे प्राप्त होणार आहे. पण फोर्स्ड कन्व्हेक्शन मध्ये आपण एक्सटर्नल डिव्हाइस यूज करणार आहे. ओके. So this is the difference between free convection and forced convection. Okay. So all of you write down the first type, free convection. Write down the first type, that is free convection. Write down free convection. The transfer of fluid. The transfer of fluid. The transfer of fluid takes place due to density difference. The transfer of fluid takes place due to density difference. The transfer of fluid takes place due to density difference. And write down the example for the free convection. Write down example. In the absence of a fan, in the absence of a fan, in the absence of a fan, heat transfer from the surface. In the absence of a fan, in the absence of a fan, heat transfer from the surface, heat transfer from the surface, heat transfer from the surface of the hot block. In the absence of a fan, heat transfer from the surface, heat transfer from the surface of the hot block, of the hot block is by natural convection, is by natural convection, is by natural convection. ओके. म्हणजे एक हॉट प्लेट आहे. ओके. आणि हॉट प्लेट वर समजा तुम्ही फ्लुइड जर पास केलं तर काय होईल? त्याचं टेम्परेचर इन्क्रीज होणार आहे त्या फ्लुइडचं. आणि टेम्परेचर इन्क्रीज झाल्यानंतर त्याची डेन्सिटी काय होणार आहे? कमी होणार आहे. and due to that density difference that molecule is moving in the upward direction. ओके, म्हणजे अशा प्रकारे काय होणार आहे, तिथे हीट ट्रान्सफर होणार आहे. म्हणजे इथं मॉलिक्युलला जी काही मोशन आहे ती कशामुळे होणार आहे, बिकॉज ऑफ दी डेन्सिटी डिफरन्स, बिकॉज ऑफ दी डेन्सिटी डिफरन्स. ओके, सो दिस इज अबाउट दी नॅचरल कन्व्हेक्शन. ओके, डेन्सिटी डिफरन्स मुळे ते मॉलिक्युल्स काय होणार आहेत, मूव्ह होणार आहेत, and because of that heat transfer is takes place, that is nothing but free convection. Okay, then write down the second type, forced convection. Write down the second type, forced convection. Write down the second type, forced convection. Write down the definition of the forced convection. The transfer of fluid, the transfer of fluid, the transfer of fluid, the transfer of fluid due to the external means, the transfer of fluid, the transfer of fluid due to the external means, due to the external means such as fan pump blower, such as fan pump blower, etc., such as fan pump blower, etc., fan pump blower, etc. Okay, तर तिथं काय आपण असं एक्सटर्नल डिव्हाइस यूज करणार आहे, मीन्स वी हॅव टू यूज दी fan, and because of that fan we giving the motion to that particular fluid. Okay, and then heat transfer is takes place from that plate to that fluid. Okay, so all of you draw that diagram for the forced convection. There is one fan, one hot plate is there, and fluid is moving in the forward direction. So this is about the free convection and forced convection, free convection and forced convection, free convection and forced convection. Okay, so this is about the what is meant by convection, then what is meant by natural convection, and what is meant by forced convection. Okay, then we have to write down the next point, law of convection. Write down the next point, law of convection. Already we have discussed this point in the unit number 1. Okay, law of conduction, then law of convection, that part we have covered in the unit number 1. So once again we have to cover for this unit, that is convection, what is the law related to the convection. Okay, so all of you write down law of convection. So what is the law related to the convection? As we know that Newton's law of the cooling is nothing but the law which is related to the convection. Okay, law of convection, law of convection, write down, the heat transfer by convection is given by, the heat transfer by convection is given by Newton's law of cooling. The heat transfer by convection is given by, the heat transfer by convection is given by Newton's law of cooling, Newton's law of cooling, Newton's law of cooling. Okay, write down the statement of the Newton's law of the cooling. So as we know that what is the statement of the Newton's law of the cooling, that is heat transfer rate per unit area is directly proportional to the temperature difference. Write down the statement, law of convection, that is Newton's law of cooling. What is the statement for that? Write down the statement, statement, the heat transfer rate, the heat transfer rate per unit area, the heat transfer rate per unit area is directly proportional to the heat transfer rate per unit area is directly proportional to the, is directly proportional to the temperature difference. The heat transfer rate per unit area is directly proportional to the temperature difference. temperature difference, heat transfer rate per unit area is directly proportional to the temperature difference. So we have to write down the in the form of equation Newton's law of the cooling. In the form of equation, write down rate of heat transfer per unit area. Rate of heat transfer is nothing but Q. Per unit area is nothing but A. So Q by A is directly proportional to the temperature difference. म्हणजे एक सरफेस असणार आहे, एक फ्लुइड असणार आहे. त्या सरफेसचं टेम्परेचर मायनस त्या फ्लुइडचं टेम्परेचर. ओके, सो ऑल ऑफ यू write down Q by A is directly proportional to Q by A. Q by A is directly proportional to delta T. Q by A is directly proportional to delta T. Q by A is directly proportional to delta T. Therefore, write down the equation as we know that for the Newton's law of cooling, what is the constant, proportionality constant? That is nothing but H, that is heat transfer coefficient for the convection. So write down the equation Q is equal to, write down the equation Q is equal to H into A into delta T. Q is equal to H into A into delta T. Q is equal to H into A into delta T. Write down the meaning of each term. Write down the meaning of each term. Q is nothing but heat transfer rate. Write down Q is equal to heat transfer rate. A is nothing but surface area. A is equal to surface area. A is equal to surface area. Delta T is nothing but temperature difference. Delta T is nothing but temperature difference. And H is nothing but heat transfer coefficient. H is nothing but heat transfer coefficient. Heat transfer coefficient. So now we have to consider one example, and for that example we have to write down the equation of the Newton's law of cooling. Okay, so write down the one example. We have to considering one body, and at the surrounding of that body there is a cold fluid. Body is having temperature is Ts, surrounding having temperature is Ta. Okay, so that is nothing but temperature difference. Q by A is directly proportional to that particular temperature difference. Okay, so write down the example. Write down. Let us consider a body is heated up to, let us consider a body is heated up to, let us consider a body is heated up to certain temperature, is heated up to certain temperature, and its surface temperature is Ts, and its surface temperature is Ts, and its surface temperature is Ts, surface temperature is Ts, and is exposed to a cold fluid, and is exposed to a cold fluid, and is exposed to cold fluid, exposed to cold fluid, which is at temperature Ta, which is at temperature Ta, which is at temperature Ta. म्हणजे काय असणार आहे, एक बॉडी आहे, त्या बॉडीचं टेम्परेचर काय असणार आहे, Ts असणार आहे, आणि त्याच्या सराउंडिंगला फ्लुइड असणार आहे, आणि त्या फ्लुइडचं टेम्परेचर काय असणार आहे, Ta असणार आहे, आणि कंडिशन काय असणार आहे, Ts इज ग्रेटर दॅन Ta. ओके, सो राइट डाउन अँड Ts इज ग्रेटर दॅन Ta. म्हणजे हीट ट्रान्सफर कुठून कुठे होणार आहे, त्या सॉलिड ऑब्जेक्ट कडून फ्लुइड कडे होणार आहे. ओके, सो Ts इज ग्रेटर दॅन Ta. ओके, फुल स्टॉप. Next line. Now the heat transfer between a body at a temperature Ts Now the heat transfer between a body at temperature Ts and cold fluid at temperature Ta and cold fluid at temperature Ta and cold fluid at temperature Ta. So therefore Q is equal to H into As into Ts minus Ta. This is the Newton's law of cooling for this particular condition. Q is equal to H into As into Ts minus Ta. AS म्हणजे काय असणार आहे? सरफेस एरिया. व्हॉट इज द मिनिंग ऑफ AS? सरफेस एरिया. ओके. सो ऑन विच फॅक्टर दिस हीट ट्रान्सफर कोएफिशियंट इज डिपेंड्स. हा जो एच असणार आहे तो कशावरती डिपेंड आहे? त्याची व्हॅल्यू कॉन्स्टंट असणार आहे का? किंवा जो सरफेस आपण घेतलेला आहे त्या सरफेसच्या कुठल्या पॅरामीटर्स वरती तो डिपेंड असणार आहे? ऑन विच फॅक्टर्स दिस हीट ट्रान्सफर कोएफिशियंट इज डिपेंड्स. ओके. सो देर आर few factors on which heat transfer coefficient is depends. Okay, first one is the fluid flow. जो काय सरफेस आहे त्याच्यावरून जे काय फ्लुइड फ्लो होणार आहे तर त्या ज्या काही फ्लुइड फ्लोच्या ज्या काही प्रॉपर्टी असणार आहे म्हणजे जो काही फ्लुइड फ्लो होणार आहे समजा ते फ्लुइड लॅमिनर मध्ये फ्लो होत असेल, समजा त्या फ्लुइडचा जो काही फ्लो आहे तो टर्ब्युलंट असेल, समजा त्या फ्लुइडचा फ्लो काय ट्रान्झिशन मध्ये असेल, तर ह्या फ्लुइड फ्लो वरती काय डिपेंड असणार आहे? तुमचा हीट ट्रान्सफर कोएफिशियंट डिपेंड असणार आहे. देन थर्मल प्रॉपर्टीज ऑफ द फ्लुइड. जे काय तुमचं फ्लुइड आहे त्याच्या काहीतरी थर्मल प्रॉपर्टीज आहेत म्हणजे त्याची थर्मल कंडक्टिव्हिटी असेल, त्याची डेन्सिटी असेल, त्याची विस्कॉसिटी असेल, ओके, त्याची स्पेसिफिक हीट असेल. तर ह्या ज्या काही थर्मल प्रॉपर्टीज आहेत त्या फ्लुइडच्या, ती प्रॉपर्टी म्हणजे विस्कॉसिटी जास्त असल्यानंतर हीट ट्रान्सफर कोएफिशियंट वेगळा असणार आहे, डेन्सिटी जास्त असणार आहे, कमी असताना हीट ट्रान्सफर कोएफिशियंट काय असणार आहे? कमी जास्त असणार आहे. ओके. सो दिस हीट ट्रान्सफर कोएफिशियंट इज डिपेंड्स ऑन दी थर्मल प्रॉपर्टीज ऑफ दी फ्लुइड. ओके. देन ज्योमेट्री ऑफ दी सिस्टीम. म्हणजे जी काय आपली सॉलिड बॉडी आहे त्या बॉडीचं जॉमेट्री कशी आहे म्हणजे ती काय प्लेन वॉल आहे का, ते सिलेंडर आहे का, स्पिअर आहे का, याच्यावरती काय डिपेंड असणार आहे? तुमचा हीट ट्रान्सफर कोएफिशियंट डिपेंड असणार आहे. देन रफनेस ऑफ दी सॉलिड सरफेस. जो काही सॉलिड सरफेस आहे त्याच्यावरून जे काय आपण फ्लुइड मोशन मध्ये मूव्ह करणार आहे त्या सॉलिड सरफेसचा रफनेस किती आहे त्याच्यावर पण काय डिपेंड असणार आहे? तुमचा हीट ट्रान्सफर कोएफिशियंट डिपेंड असणार आहे. देन ओरिएंटेशन ऑफ दी सरफेस. सरफेसचं ओरिएंटेशन कसं आहे? ओके. त्याच्यावरती पण काय डिपेंड असणार आहे? ओरिएंटेशन ऑफ द सरफेस आवर हीट ट्रान्सफर कोएफिशियंट इज डिपेंड्स. ओके. सो ऑल ऑफ यू राइट डाउन. द हीट ट्रान्सफर कोएफिशियंट इज function of the heat transfer coefficient is function of the heat transfer coefficient is function of, write down first, fluid flow. Write down first fluid flow in bracket, that is laminar, transition or turbulent. There are different types of flow. Is there laminar, turbulent, transition? Okay. First is fluid flow in bracket laminar, transition or turbulent. Then second, thermal properties of fluid. Thermal properties of fluid. So in that we have to write down like K, that is thermal conductivity, rho density, mu viscosity, Cp specific heat. Write down thermal properties of fluid in bracket like K, rho, Cp, mu, etc. Okay. Then third, geometry of the system in bracket plane wall, cylinder, sphere. So these are the some of the geometries. Okay, write down the geometry of the system in bracket plane wall, cylinder, sphere, etc. Then next point, D, roughness of solid surface. roughness of solid surface, roughness of solid surface, and then last point, that is E, orientation of surface, ओके. तर हीट ट्रान्सफर कोएफिशियंट कशा कशावरती डिपेंड असणार आहे, त्या फ्लुइडचा फ्लो कसा आहे, त्याच्या थर्मल प्रॉपर्टीज काय आहेत फ्लुइडच्या, त्याची जॉमेट्री कशी आहे, रफनेस काय आहे सरफेसचा, आणि त्याच्यानंतर ओरिएंटेशन कसं आहे. ऑन दिस फॅक्टर्स हीट ट्रान्सफर कोएफिशियंट इज डिपेंड्स. आता समजा एक सरफेस आहे, तर त्या सरफेसवरून आपण फ्लुइड फ्लो करतोय. ओके, वी हॅव टू कन्सिडर वन surface is there and on that surface we are flowing the fluid. Okay, so at each location there should be different heat transfer coefficient is there. आपण असं म्हणतोय की Q is equal to H into A into delta T, म्हणजे H आपण कॉन्स्टंट युनिफॉर्म कन्सिडर करतोय. We have to considering the H is constant over that particular surface, but actually this heat transfer coefficient is not uniform over that particular surface. प्रत्येक पॉइंटला हीट ट्रान्सफर कोएफिशियंट काय असणार आहे, वेगळा असणार आहे. म्हणजे जे काय आपण इक्वेशन यूज करणार आहे, Q इज इक्वल टू H इंटू A इंटू डेल्टा टी, हे इक्वेशन तिथे युजफुल नाही आहे, लक्षात ठेवा. We are using the general equation as a Q is equal to H into A into delta T, but actual conditions H is not uniform over that particular section. Okay, so this equation is fails to solve that particular problem. हे इक्वेशनचा यूज करून आपण तो प्रॉब्लेम सॉल्व्ह करू शकत नाही. So we have to use the different conditions, or we have to use the different analysis, different mechanisms, different theories, and that is nothing but dynamics of fluid flow. ओके, तर त्याच्यासाठी आपल्याला त्या फ्लुइडचं डायनॅमिक्स समजून घ्यायला पाहिजे. ओके, सो ऑल ऑफ यू राईट डाऊन दिस इन्फॉर्मेशन, राईट डाऊन, एरो करून लिहा. द न्यूमेरिकल व्हॅल्यू ऑफ हीट ट्रान्सफर कोएफिशियंट, the numerical value of heat transfer coefficient is not uniform over the entire surface. The numerical value of heat transfer coefficient, the numerical value of heat transfer coefficient is not uniform over the entire surface, is not uniform over the entire surface, over the entire surface, and it is dependent on, and it is dependent on at which, and it is dependent on at which location, at which location, at which location we have measured the temperature, we have measured the temperature, we have measured the temperature, full stop. Next arrow, next line, at which location we have measured the temperature, full stop. Next line, arrow. Therefore equation 1 fails to, therefore equation 1 fails to give the, therefore equation 1 fails to give the exact numerical value of heat transfer coefficient. Therefore equation 1 fails to give the exact numerical value of heat transfer coefficient, heat transfer coefficient for calculating exact value of H, for calculating exact value of H, exact value of H, we have to study different theories. For the calculation of exact value of H, we have to study different theories, different theories. आपल्याला जर करेक्ट व्हॅल्यू याची फाइंड आउट करायची असेल तर आपल्याला काय करायला लागेल, वी हॅव टू अंडरस्टूड दी डिफरंट theories, comma mechanisms, comma mechanisms, comma dimensions, dimensions numbers, dimensions नंबर किंवा त्याला डायमेन्शन लेस नंबर असं म्हटलं जातं, डायमेन्शन लेस नंबर्स एटसेट्रा, डायमेन्शन लेस नंबर एटसेट्रा. टू अंडरस्टँड ऑल दिस, to understand all this, To understand all this, we must know the to understand all this to understand all this, we must know the dynamics of fluid flow. We must know the dynamics of fluid flow. तर आपल्याला काय समजून घ्यायला लागेल, तर त्या फ्लुइडचे जे काही डायनॅमिक्स आहेत ते आपल्याला समजून घ्यायला लागेल. म्हणजे फ्लुइड मध्ये कुठले कुठले प्रकार असणार आहेत, त्याच्यानंतर विस्कॉसिटी मध्ये काय काय आहे, त्याच्यानंतर त्याचे रिलेशन कुठले आहेत हे आपल्याला काय करायला लागेल, समजून घ्यावं लागेल. आणि फ्रॉम दॅट वी हॅव टू find out the exact value of H by using the different correlations. Okay, so write down the next point, dynamics of fluid flow. Write down the next point, dynamics of fluid flow. ऑलरेडी हे आपण फ्लुइड मेकॅनिक्स मध्ये शिकलेलं आहे, डायनॅमिक्स ऑफ फ्लुइड फ्लो. आयडियल फ्लुइड म्हणजे काय, त्याच्यानंतर रिअल फ्लुइड म्हणजे काय, विस्कॉसिटी म्हणजे काय, डायनॅमिक विस्कॉसिटी म्हणजे काय, कायनॅमेटिक विस्कॉसिटी म्हणजे काय, व्हॉट इज द न्यूटन्स लॉ ऑफ विस्कॉसिटी काय आहे. तर हे आपण डायनॅमिक्स ऑफ फ्लुइड फ्लो म्हणजे हे आपण ऑलरेडी फ्लुइड मेकॅनिक्स मध्ये शिकलेलं आहे, ते आपण फास्ट मध्ये घेणार आहे. सो राईट डाऊन द डायनॅमिक्स ऑफ फ्लुइड फ्लो. फर्स्ट राईट डाऊन द आयडियल फ्लुइड. So as we know that what is meant by ideal fluid, the fluid having no viscosity. ज्या फ्लुइडची विस्कॉसिटी 0 असणार आहे ते फ्लुइड म्हणजे आयडियल फ्लुइड असणार आहे. ओके, तर असं फ्लुइड अस्तित्वात नाहीये. ओके, सो राईट डाऊन फर्स्ट dynamics of fluid flow. Write down the first fluid as the ideal fluid. Ideal fluid. Ideal fluid. Write down the fluid having no viscosity. ज्या फ्लुइडला विस्कॉसिटी नाही आहे त्या फ्लुइडला आयडियल फ्लुइड म्हटलं जाते. सो राईट डाऊन द फ्लुइड हॅव्हिंग नो विस्कॉसिटी. The fluid having no viscosity is known as ideal fluid. The fluid having no viscosity. The fluid having no viscosity is known as ideal fluid. Is known as ideal fluid. The fluid having no viscosity is known as ideal fluid. Ideal fluid. Full stop. Next line. Such fluid not exist in nature. 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 Okay, full stop. Next line. However, fluid which have low viscosities. However, fluid which have low viscosities. However, fluid which have low viscosities. Low viscosities, such as water and air. However, fluid which have low viscosity such as water and air can be treated as can be treated as can be treated as ideal fluids under certain conditions. Can be treated as ideal fluids under certain conditions. Under certain conditions. Under certain conditions. Okay, so this is about the ideal fluid. Then write down the real fluid. Write down the real fluid. Write down the real fluid. So as we know that ज्या फ्लुइडला विस्कॉसिटी असणार आहे त्या फ्लुइडला काय म्हटलं जाते, रिअल फ्लुइड म्हटलं जाते. सो राईट डाऊन द फ्लुइड विच possesses viscosity. The fluid which possesses the fluid which possesses viscosity. The fluid which possesses viscosity is known as the fluid which possesses viscosity is known as real fluid. Is known as real fluid. Is known as real fluid. Full stop. Next line. The real fluids are actually available in nature. The real fluids are actually available in nature. The real fluids are actually available in nature. Okay, so this is about the real fluid. Then write down the third point, that is viscosity. Viscosity. Okay, तर viscosity म्हणजे काय असणार आहे? Can anyone tell me what is meant by viscosity? Resistance to flow. Okay, जी प्रॉपर्टी जी काय फ्लुइड आहे त्या फ्लुइडला मोशनला रेजिस्ट करणार आहे दॅट इज नथिंग बट विस्कॉसिटी. म्हणजे जास्त विस्कॉसिटी असली तर त्याची मोशन काय असणार आहे, रेजिस्टन्स काय असणार आहे, जास्त असणार आहे. ओके, सो रेजिस्टन्स टू फ्लुइड इज नथिंग बट viscosity. Okay, write down resistance to flow, viscosity. Resistance to flow is nothing but resistance to flow is nothing but viscosity of a fluid. विस्कॉसिटी ऑफ फ्लुइड. आता वॉटर आणि मर्क्युरी जर आपण कन्सिडर केलं तर मर्क्युरीची विस्कॉसिटी जास्त आहे. ओके, ऍज कम्पेअर टू दी वॉटर. Resistance to flow is nothing but viscosity of fluid. The next line, viscosity is primarily due to the cohesion and molecular movement exchange between fluid layers. जे काय दोन फ्लुइडचे लेअर असणार आहेत, म्हणजे एखादं फ्लुइड जर कन्सिडर केलं तर त्याच्यामध्ये नंबर ऑफ लेयर्स असणार आहेत. एक लेअर दुसऱ्या लेअरवरती शेअर स्ट्रेस ऍक्ट करणार आहे, दुसरा लेअर पहिल्या लेअरवरती शेअर स्ट्रेस ऍक्ट करणार आहे. ओके, अँड बिकॉज ऑफ दॅट resistance will be arises. Okay, so all of you write down viscosity is primarily due to the cohesion and molecular movement exchange. Viscosity is primarily due to cohesion and molecular movement exchange between fluid layers. Molecular movement exchange between fluid layers. Okay, so all of you draw this diagram. There we have to considering the two layer. One layer is having velocity u, another layer having velocity is u plus du. Distance between these two layer is dy. Okay, there is a solid boundary, and on that boundary fluid is moving. All of you draw this diagram. Draw this diagram. Okay, so as we know that top layer causes a shear stress on the adjacent bottom layer, while the lower layer causes a shear stress on the adjacent top layer. And as we know that this shear stress is directly proportional to the rate of change of velocity with respect to distance. Okay, so tau is directly proportional to the du by dy. So from that we get the equation as a tau is equal to mu into du by dy. And from this equation we get the equation for the mu is equal to tau into du by dy. So viscosity is also defined as the shear stress required to produce per unit rate of shear strain. And what is the unit of the viscosity? SI unit is Newton second per meter square. Then MKS unit is kgf second per meter square, and CGS unit is poise. Okay, so all of you write down this information. The top layer causes a shear stress on the adjacent bottom layer. Write down that information. All of you complete this page up to the units of the viscosity. Already we have all of you write the information up to the CGS unit, that is unit of viscosity, that is poise. आपल्याला सगळ्यांना माहिती आहे, ऑलरेडी आपण हे शिकलेलं आहे फ्लुइड मेकॅनिक्स मध्ये विस्कॉसिटी म्हणजे काय. फक्त आपल्याला बेसिक्स माहिती असावं ह्याच्यासाठी मी परत घेतलेलं पॉईंट विस्कॉसिटी. सो ऑल ऑफ यू कंप्लीट दिस information. Write down that all information. The top layer causes a shear stress on the adjacent bottom layer, while the lower layer causes the shear stress on the adjacent top layer. So all of you complete this page up to the unit of viscosity. Okay, write down the units of the viscosity. SI unit Newton second per meter square. MKS unit kgf second per meter square. CGS unit is poise. Okay, so here we have to stop. Remaining part we have to take in the tomorrow's lecture. So all of you put your roll numbers in the chat box. Okay, sir, stop the recording and leave the meeting.